Hello, it's Valentine from Simplistic, and in this video we're going to take a look at a problem which asks us to choose which acid. We have four choices. Let me just go ahead and write that down. 1, 2, 3, and 4. We have four choices of acids, and it's asking you which acid would you choose to combine with its sodium salt to make a solution buffered at pH 7.35. All right, and it's saying for the best choice, calculate the ratio of the conjugate base to the acid required to attain the desired pH. Now you can do that, but I'll tell you right now that for the best choice, the ratio of the conjugate base to the acid is actually 1:1. Okay, that's usually the best choice. Okay, and that being said, if you put that into the Henderson-Hasselbalch equation, which I'll write down as pH is equal to pKa plus log of concentration of base over concentration of, it's a little bit of static out there, concentration of acid. And if the ratio is 1:1 between the base and the acid, then that simplifies to pKa plus log of 1/1, which is equal to pKa plus log of 1. This actually, log of 1 is equal to 0. So that's equal to the pKa. So this simplifies to pH is equal to the pKa. So out of the choices given to us, 1.95, 3.34, 3.74, and 7.54, you will choose the one that whose pKa matches basically comes very close to the pH that you're trying to create the buffer at. So therefore, since we're choosing the buffer we want to make, we want the pH to be 7.35. Out here, we will choose this acid, hypochlorous acid, because its pKa is 7.54, which is very close to the buffer of choice. All right, so once we have that, once we kind of made that choice, let's take a look at what the ratio ends up being. Okay, so let's go ahead and plug those values into this equation. So we get pH is 7.35, that's given to us. pKa is 7.54 plus log of base over acid. Let's call that ratio. Let's call this ratio x. So log of x. And we simplify that, we combine terms, we get negative 0.19 is equal to log of x. So x is equal to 10 raised to negative 0.19, which is equal to 0.6456. So that's the ratio of base to acid. Concentration of base to concentration of acid. All right, so once we have that, now the next part of the question is asking us, if you have 500 ml of a 0.10 molar solution of the acid, what mass of the corresponding sodium salt of the conjugate base do you need to make the buffer? So to determine the mass, we need to understand that mass can only be calculated once we know the moles and the molar mass. The molar mass we can find out because we know what acid we're going to choose. So we just have to replace the H out here in the acid with the sodium, and then compute the molar mass. For the moles, we have to use the volume and the concentration of the acid to determine the moles. Okay, so let's go ahead and do that. So since let's see. So the number of moles of acid, let's call that N acid, would be equal to, we're going to use this formula, moles is equal to molarity times the volume. So the molarity given to us is 0.10, and the volume is 500 ml. We have to convert that to liters, so that's 0.500 liters. And we multiply that together, we get 0.05 moles. Okay, now it turns out we're going to put this number into this equation. Okay, why? Because the concentration of base is the same as number of moles of base over total volume, and that whole thing is divided by number of moles of acid over total volume, and that is equal to 0.6456. So the volumes cancel out. We know the moles of acid, which we just figured out. So number of moles of base over 0.05 is equal to 0.6456. And that gives us moles of base is equal to 0.03228. But that's the moles of base. So now let's figure out the molar mass. So if the acid is HClO4, the conjugate base would be ClO4 minus, and then the sodium salt of this is going to be NaClO4. The molar mass of this sodium salt is equal to 22.990 plus 35.45. We're just pulling these numbers from the periodic table, plus 15.999. You might want to pause the video and kind of pull these numbers yourself and kind of add them up. That gives us 74.439 grams per mole. So once we have that, so now we have the molar mass and we have the moles. So now the last step is to calculate the mass. So the mass of NaClO4, which is the sodium salt of the conjugate base, is equal to moles times the molar mass. So moles is equal to 0.03228 times molar mass is 74.439 grams per mole. And this one I'm going to write this as moles. That gives us 2.4 grams, which is the correct answer. I hope that made sense. Thank you for watching.